All right, so here's the warm-up. Pause if you still need to do this. And here are the answers. Okay, so basically on the first one, if we take the 2 and we distribute it, distributing, the word in the English language to distribute is like kind of like to hand out. Like if you were feeling really generous one day and you made a whole bunch of sandwiches and you wanted to go distribute them to homeless people downtown Portland, or actually anywhere in Portland, there's a lot of homeless people right now. You'd be distributing sandwiches. So that's the same kind of idea. We're distributing the 2, we're passing it out to this x, and 2 times x gives you 2x, and then 2 times 5 gives you 10. So you just do 2 separate sub-problems. Okay, same thing with this one. You distribute the 4 into the parentheses, so it's 3 problems. It's going to be 2 or 4 times x squared, which is 4x squared, 4 times 6x, which gives you 4 times 6 is 24, and it still has the x, and 4 times 3 gives you negative 12. Okay, I am looking at the chat, so if I'm going too fast, let me know. All right, next one, 6x. This is a little different because it has an x. So you start with a number. I start with the numbers. 3 times 2 gives me the 6. But let's talk about x times x squared. When you multiply those things, it is not, we're not doing x plus x squared. Okay, that's not what we're talking about. We're doing x times x squared. Now x times x squared is x times x. So really there's 3 x's there, which makes x cubed. And that's how we get that x cubed right there. Okay, insert question here. Next we go 3x times negative 7x. 3 times 7 gives you 21 and it's negative. And then x times x gives you x squared. And then 3x times 1 is just 3x. All right, what questions do you have on the first set of problems? Okay, one thing I want you guys to notice is all of these are in standard form. All answers are in standard form. Okay, standard form means that the x cubed, the higher power comes first, and then the next power down, so it goes x cubed to x squared to regular x. If, so here's non-standard form. It would look, that looks weird. Dots there. It would look like if I wrote it as negative 21x squared plus 6x cubed plus 3x. Notice that I switched these two terms. Okay, those are not in descending powers of x. We start with an x squared here, and then it goes up to x cubed, and then down to x, regular x. So this is not standard form. It's not wrong. It's just not the right way that we're used to writing this in mathematical notation. So when you do the Go formative today, it's going to ask you to write all your answers in standard form, where you start with the highest power of x. Okay, any questions on that? Okay, let's look at the bottom part. The bottom part is like going backwards. It's saying what number goes into 6 and 15, both equally, or both evenly, and that would be 3. Okay, 6 divided by 3 gives you 2, and 15 divided by 3 gives you 5. So if you were to think about this like we did these problems, you can multiply 3 times 2, that would give you 6x, and multiply 3 times 5 give you 15. Same thing here, if I were to multiply this, 4 times 2 gives you 8, and x times x gives you the x squared. 4 times 11 gives you the 44 with the x. Okay, pay careful attention to positives times negatives give you negatives. And then over here, what's in common in all of these is a 2 for the number. 2 goes into 10, 2 goes into 2, 2 goes into 6. But there's also an x squared inside there, because if you think about this, x to the 4th is like x times x times x times x. X cubed is like x times x times x, and x squared is 2 x's. And so here I've got 2 x's. Here I've got 2 x's with 1 left over. Here I've got 2 x's with 2 left over. The leftover parts are what's left over. The leftover part here is what's left over. And there's nothing left over here. Does that make any sense at all? What questions do you have on that one? Okay, we're going to roll forward here then. Let me pause the recording. Okay, let's go on to an example of the distributive property. We're going to look at this even further and expand this idea. First up, I'll give you a second to write that down. If you don't already have this in your notes, you want to write distributive property and then write what it is. Okay, let's look at an example of a rectangle. You know from geometry that if you're going to find the area of a rectangle, it would be length times width. And so 3 times 8 gives you 24, right? But what if we were to divide that rectangle into a piece, like into parts? What if I wanted to like cut it off? We would have like region 1 and region 2. If I were to add those two rectangles together, they'd still be equal to the whole rectangle, right? So that's what's going on in the next example is I take the number 2 or the number 8 and split it into the number 2 and the number 6. 2 plus 6 is 8. So if I cut it right here, 2 times 3 gives me 6, and 3 times 6 gives me 18. And if I do 6 plus 18, I get the same answer as before, 24, because it's the same rectangle, right? We're going to use this kind of idea, and this maybe seems silly. Why wouldn't you just multiply 3 times 8 and be done? Well, there's a reason, okay? We're going to be doing these problems with variables and letters and things and less numbers. So working symbolically, this idea of a rectangle is going to be really helpful for solving some problems, okay? All right, I'm going to move forward on that. You could take a picture, I suppose, but this will be on Canvas. Okay, going forward, let's do this together, and then I'm going to have you do a couple on your own. Okay, so first of all, I'm going to think about this rectangle idea. So take a second in your notes and draw a fairly clean rectangle. It doesn't have to be with a ruler or anything. And you're going to write inside of this, so make sure it's not too small. All right, think of this as my length of the rectangle and this is my width of the rectangle. Or base and height, or however you want to do that. So I'm going to think of this as my length and this is my width. And since the length is x plus 2, I'm going to write it down like that. Now there's two parts to that. There's an x and there's a plus 2. So kind of like on the previous example, I'm going to divide this rectangle down the middle. Okay. There's also two parts to the width. There's b and there's plus c. So I'm going to divide that this way. Now I have 4 sections in the middle. Well, the reason for this is because when you're multiplying two things like this, there's a term here and a term here, and there's 2 numbers in each, or letters. Those are called binomials. Like a bicycle has 2 wheels. Okay, so this is the first binomial, which represents our length, the second binomial, which represents our width. Now, if I want to find out what the product of these two things is when I multiply them, it's going to be the area of all 4 of these rectangles added together. So I can just find one of the rectangles at a time, and I have 4 small problems that I have to do. So this first one is going to be x times b, but don't write xb. It's typically written b times x. So we've got bx. This next one over here is still x by c, x by c, so it's cx. Hey, shout at me in the chat, or just unmic and shout at me if I'm going too fast, okay? All right, this one right here is going to be 2 times b, and this one over here is going to be 2 times c. So we've got 2b and 2c. Okay, so if I were to write out my answers, I actually have 4 parts of this. I have this, which is going to be bx. I have this one, which is plus cx. This one, which is plus 2b. And the last one, plus 2c. So those two expressions are equal to each other. Yeah, it is kind of like a Punnett square for genes in biology. It is kind of like that. So it allows you to do 4 separate small problems and keep everything organized, okay? What about the addition signs? So the thing with the addition signs is it works out. If you do a plus c times a plus 2, you get a plus 2c, and that's why there's a plus right there. If this is even though it doesn't have a plus next to the b, it's a plus b, it's not negative. So it's a positive times a positive, which gives you a positive. You will see some examples soon where there's negatives in here, and then you just have to be a little bit careful as you fill out the table. Okay? Where do they go? Okay, so hopefully that helped with that, and you're going to see some more examples with signs and stuff. Okay, moving on, last chance for a photo if you want it. Okay, moving on here. All right, I'm going to do the first one, and then I'm going to have you guys try the second one. So if you've done the first one faster than me, because you kind of understand this, you can go on to the second if you want to. Okay, so for each of these, we're going to make a rectangle. So just focus on number 1 for a second here. Let's not get ahead of ourselves. I was just trying to say if you're understanding and moving faster, it's fine. Okay, so in each of these, I'm making a little rectangle with my lines in there. And remember, this is my length and this is my width. So for my length, it's going to be x and plus 2. Technically, you don't even have to write the plus. It's positive, so it's fine. And the other one's going to be x and plus 3. So in the first box right here, it's going to be x times x, which is x squared. The next box, x times 3, 3x. Going down below here, 2 times x gives you 2x. And the next one here gives you 2 times 3, which is 6. Okay, what's interesting with this problem is look at the middle terms right there. We're going to add all of these up. Okay? The middle terms together is a 2x and a 3x. Those are like terms. If you have 2x's and you have 3x's, then altogether you have 5x's, right? So this whole thing right here is actually equal to 5x. So my first term in my answer is going to be x squared. The middle ones combine to plus 5x. So this is a new idea. We haven't seen that yet. And then the last lonely little 6 at the end. Aww. Okay. What questions do you have about number 1? Okay, why don't you take 2 to 3 minutes and try number 2. If you're done before I come back, I encourage you to look away from your screen for a couple minutes. Okay, so we'll go till 1:55 for this. Okay, so if you're done early, take a little break if you need to, but come right back at 1:55. It's only 3 minutes away. Okay, so isn't 2 plus 3 5, not 6? 2 plus 3 is 5. That's that middle number. This number out here came from 3 times 3 because the area of a rectangle is length times width. So 2 times 3 gives you the 6. There's a lot of different things going on in there. Okay, I'll stop talking so you can think. Okay, let's do number 2. So basically, I'm going to make a rectangle again. Divide it into 4 sections. There are other ways to do this too. Okay, if you look up multiplying binomials, on YouTube, you're going to find tons and tons of people explaining this to you, okay? This is a classic thing in algebra class. So, all right, this is my length, this is my width. So this is my x plus 5, and this is my 2x plus 7. So this is a new idea. This idea of having a 2x there, that's something a little bit different. Okay, so then we figure out what our length times width is. It's an x by 2x. So it's going to be 2 times x times x. 2 times x times x is 2x squared. Okay. All right. And then the next one is going to be x times 7, which will give you 7x. And then down here is a 5 times 2x. So you just do the numbers. 2 times 5 is 10, and then it has an x. Then we have a 5 times 7, which will give me a 35. Okay, then you look for any common terms. This one right here is the only one that has an x squared in it. This right here are like terms. They both just have x's, so I can combine them. And I do 10x plus 7x, and I get 17x. So that's the real number there in the middle, and the 35 is just all by itself. Okay, so then we write our answer, 2x squared. It's the only one that has an x squared. The 17x, so plus 17x, and then plus that lonely 35 at the end. Okay, so that's our answer. All right, what questions do you guys have about that? Okay, moving on. Let's do one of these that has a negative. So this is our first one that has a negative in it. This was a question that came up in the chat privately here. You start the same exact way. Okay, so I'm going to go through this with you. Why don't you take a second and write the problem down and make your box. Okay, and then this is our length and this is our width. Hey, if you mix up the length and the width, it doesn't matter, you'll get the same answer. I mean, really, try it if you don't believe me. It's just like, same thing with calculating the area of a rectangle. Say you had a rectangle that was like a 2 by 3, and you did 2 times 3, you get an area of 6. Well, what if you did 3 times 2? It's still 6. I'm going to close this door real quick. Sorry about that. Okay, so let's write down what the length and width is. It's an x and it's a minus 7 this time, and an x and a plus 8. Okay, so in our first box, it's x times x, which is x squared. Next box is 8 times x, which is 8x. The next one is going to be a 7 by x. Length times width, every single time I'm just doing area. So that's a negative 7x. So that's where our negatives are coming in here. And the last one is a negative 7 times a positive 8, which is negative 56. Okay, the only x squared. So that means our answer is going to have an x squared in it. These two are alike. Noticing a trend, that's usually what happens. Not always, but it's usually what happens. And if I combine those two things, it's 8x plus a negative 7x. Plus a negative is just the same thing as subtraction. So that gives you 1x. And 1x is the same thing as just adding x. You don't have to write the 1. You can if you want to. And then the negative 56 goes at the end. Okay, so that's our answer. Am I going way too fast? What's going on here, you guys? Okay, you ready to try one? Sweet, good. I'm glad you're getting it. Okay, so these are hard though, okay, right? I mean, these problems aren't any harder than the last ones, but all this stuff we're doing today is new and it's maybe challenging. Okay, last two problems. Try the first one. If you have time, try the second one, but don't worry if you don't get to it. Okay, so these involve negatives now. So do what you can in the next 3 minutes. And if you don't get all the way through problem 5, it's okay. All right, I'm going to show you my answers And we can talk about it real briefly here. Okay, so here's what I got. Just take a second and check your thinking there. What questions do you have? This page is a really good summary of everything we've done because we have all of the, this is all positive and then this is negative answers. And notice that we had a negative result here in here, which gave us a negative 11. But down here, it turned back positive because a negative times a negative is a positive. So that's why there's a plus 30 at the end. So you can have signs here that are mismatched, that are not the same every time. That's okay. Notice also that all of these are in descending form. So it goes x squared and then the regular x and then nothing at all. X squared, regular x, nothing at all. So that's also called standard form. And the very first question about the Go formative is going to talk about that, okay? So if you have difficulties with that, you can let me know too. All right, I'm going to move this page forward. The last thing that we have, so that's it for notes, but if you want more help on this, like I had mentioned, do a Google search for multiplying binomials, and you're going to find all kinds of things, or do a search on YouTube, actually, that might be more helpful. And then you can also look back at this recording on Canvas. Okay, so let me